Welcome to the Bible and Science. This is Dave Prentice. I'm a retired public high school teacher, certified in all branches of science and math. I've also taught on the Bible and Science for many years, both in the U.S. and on many overseas mission trips. This is episode 48 of the Bible and Science. In the last few episodes, we've been talking about the supposed evolution of one type of animal to another type, and we talked specifically about where did mammals come from? Could they have come from reptiles? Now we're going to get into some of the diversification, evolutionists would say, of mammals. Why are all of the different types of mammals in the world? Could they have come from common ancestors? So I look at exactly the same fossils when I go to a museum as an evolutionist does, but I interpret them according to certain presuppositions. I believe that in the beginning, everything was already complex, organized, and that later it would have deteriorated and lost information content. An evolutionist would look at the fossils in the museum and say, no, they had to evolve, they had to gain information content. So creation says complex to simple, evolution says simple to complex. And we're both biased as we look at the world around us today and as we look at the fossil record. So we are looking at the same evidence, both creationists and evolutionists. You're going to see my interpretation, which is from the perspective of recent creation. So when we talk about where mammals came from, supposedly they would have started from some sort of an ancestral fish way back when. And that fish evolved and it gave rise to the jawless fish and the jawed fish. And the jawed fish, those with cartilage and those with bones, the osteichthyes. And then those with bones would have gone to the coelacanth, which supposedly evolved onto land. And then also there would have been the tetrapods, the four-legged or four-limbed creatures that eventually wound up on land. These would have given rise to amphibians. You have different types of amphibians, and the modern amphibians, there are three types. Extinct, there are a number of them, and somehow those are supposed to have evolved and led to various kinds of reptiles like turtles, lizards, snakes, marine reptiles, flying reptiles, dinosaurs, and so forth. And somewhere along the way, one of those groups is supposed to have evolved into mammals. So there are three major groups of mammals that we're going to talk about. One is monotremes, we've dealt with before. Another is marsupials, pouched animals. And another one is the placentals, the ones that nurse their young with a placenta. And this is going to include the primates, which we'll get to in a few episodes from now. So according to initial complexity, mammals did not evolve from something else. They were brought into existence fully formed. And this, of course, requires intelligence. It's not going to happen just by random. According to evolution, which is initial disorganization with later increase in complexity, life began as a chemical accident somewhere around 3.5 billion years ago. So DNA, we've gone over this before, self-assembled through some unknown process. Then there were copying mistakes called mutations that led to all of the following. So for about 3 billion years before the Cambrian times, Cambrian rock layers, the descendants of the first living cells diverged into animals, plants, fungi, and so forth. Some of those one-celled animals are supposed to have evolved into multi-celled forms. And among the multi-celled forms, some of them are supposed to have evolved into soft-bodied invertebrates. Some of those soft-bodied invertebrates are supposed to have developed a structure which evolved into a backbone. Okay, so now we have vertebrates. Some of those vertebrates became fish. They went from some sort of a cartilage type nodal cord to an actual backbone. Then one group of the fish left the water and became what we call the stem amphibians. Those would have diversified into 9 known orders of amphibians, 3 living and 6 extinct. And also some of those would have had to turn into the stem reptiles, which continued to evolve into many different types of reptiles. One of those reptile types evolved into mammals, another into birds. And then the mammals evolved into over 30 separate orders. It's difficult to say exactly how many because it on who is doing the classifying. But on the geologic time scale, we've talked before about some of the timing of the reptiles, and then you got to the Morganucodons that were claimed to lead to the earliest mammals, and that would have led to a few types of mammals, the monotremes, the marsupials, and the rodents. But then within the last 50 million years or so, there's supposed to have been an explosive appearance of modern mammals, and then the primates came along among the last ones. Okay, so let's talk about mammals. The classification system is kingdom, phylum, class, order, family, species, genus, and species. And the orders of mammals, the extinct ones that we know of, are Amblypoda, Astropotheria, Condylarthra, Creodonta, Desmostylia, Ambrithopodia, Litopterna, tubular, oh, sorry, this is tough, Multituberculata, ungulates are hoofed animals, and then Pantotheria, Pyrotheria, which were elephant-like ungulates. You had Taeniodonta, Tilodontia, Trigonostylopia, and Xenunculata, which are South American ungulates. Okay, then the living orders, the placental mammals that we see in the world today. There are a number of different classification systems. I'm going to use the one that's found in Encyclopedia Britannica. You'll see that there's order Aphosauricida, Artiodactyla, Carnivora, Cetacea, Chiroptera, Cingulata, Dermoptula, Aranacea, you try to say this in a hurry, Hyracoidea, Lagomorpha, Macroscelidia, Perissodactyla, primates, Proboscidea, Rodentia, Sauricomorpha, used to be called Insectivora, Scandentia, Sirenia, and Tubulodentata. These are all of the types of mammals that are living in the world today, as far as I've been able to determine the classification. So we're going to focus today on the order that includes whales, porpoises, and dolphins. That's order Cetacea. So there are also living orders of marsupials and monotremes, which were covered in an earlier episode. The marsupials include the numbats, which was an extinct Tasmania wolf. They're American short-tailed opossums, and then they're Australian possums. A possum is not the same as an opossum. There's only one living species of Microbiotheria, order Notorostemorphia, marsupial moles, and then there's shrew-like insectivores, bandicoots, and bilbies. So at my church, I wished everybody a happy Easter and showed them the Easter bilby. Down in Australia, people don't necessarily like rabbits. Rabbits were an invasive species, so they don't have the Easter bunny. They do the Easter bilby. The monotremes include the platypuses, order Platypoda, and the spiny anteaters, or echidnas, which is order Tachyglossa. Okay, so why are there similarities and differences in both living and fossilized organisms? According to initial complexity, creation, complex to simple, similarities are due to common design. It definitely requires an outside influence. That would be an intelligent being, that is God. The differences would be due to built-in genetic variation. It wasn't take any specific amount of time. This would allow for a relatively short time frame, and catastrophic events, floods, volcanic eruptions, and so forth, would be considered possibility. Then evolution, initial disorganization, simple to complex, would say that the similarities between the various types of critters are due to common ancestry, and the differences must be due to random evolution, that is, mutations. There would be hundreds of millions of years, in fact, billions of years since the first living things. No catastrophic events would be allowed, only uniformitarianism, uniform processes, slow, steady, gradual. So the idea of simple to complex, which evolution depends upon, requires a matter of faith. Now, initial complexity certainly requires faith. It implies the existence of some sort of intelligent being. But initial disorganization, simple to complex, requires either that you believe DNA did not evolve for billions of years, and the first living things used some unknown, far simpler information storage system. They not have any error correcting mechanisms at all. So what we see today are very elaborate error correcting mechanisms. Those had to be added to the DNA later by mutations in the DNA itself, one mutation at a time. So that means that the intricate system of enzymes that prevent errors had to be the result of thousands of perfectly coordinated errors. So errors produce the error prevention mechanism. Or if you're a theistic evolutionist, a lot of theistic evolutionists would say, well, okay, we'll kind of throw God a bone and say maybe he exists. So there must have been some intelligent being that added the error correcting mechanism much later, but he had to override it millions of times because he was determined he really wanted to have evolution. The error correcting mechanisms in DNA don't enable evolution, they prevent it. So going back over what we talked about earlier about monotremes, they lay leathery eggs which hatch after about 10 days, and the babies actually go through most of their embryonic development after hatching. They can't survive on their own. They remain in a nest and they nurse for several months. Monotremes don't have teats to nurse, but the babies lick milk off a mammary patch on the mother's abdomen. They also have no stomachs. They digest nutrients directly from their intestines. So monotremes are classified as cynodonts, which is a word for dog teeth. Nevertheless, echidnas never have teeth. And platypuses only have teeth for a short time, and they lose them immediately after infancy. So we call them dog teeth, even though they don't have teeth. The platypus has webbed forefeet. They have clawed hind feet, a beaver-like tail, a leathery bill that looks like a duck bill, but it has electric sensors. What? Electric sensors? Yes, that allow it to detect small prey in the mud. The males have spurs on their hind feet that are attached to poison glands. And quick recap of marsupials. They give birth to very immature babies, which crawl back into a pouch on the front of the mother, and there they latch onto a teat until they're mature enough to evolve several months later. There are about 250 known living and fossil species of marsupials. The method of reproduction is very much different from placentals, but many marsupials have close non-marsupial equivalents. For instance, kangaroos in many ways are like deer. Sugar gliders are like flying squirrels. Wombats are like groundhogs. Tasmanian devils are like wolverines. Quolls are like cats, as well as marsupial mice, rats, wolves, and extinct marsupial rhinoceroses and panthers. They're not supposed to have come from a common ancestor. It's supposed to be just an accident of evolution. And if you live in the United States, you've probably seen opossums somewhere. I live in South Louisiana, and there's a joke that I like to tell. Why did the chicken cross the road? To show the opossum that it really was possible. Because opossums tend to get squished on the road. So the opossum is virtually, so they were trying to show the opossum that it really was possible. That's why the chicken crossed the road. Okay, the opossum is virtually unchanged from fossil specimens dated to about 65 million years ago. The Virginia opossum, there's a picture of one right on the screen there, and then the Australian brush-tailed possum. Possums are not the same as opossums. They're a different group of marsupials. Tasmanian devils, if you've ever enjoyed Bugs Bunny cartoons, you've probably seen the Tasmanian devil. It really doesn't look very much like this. But the sugar glider is like an equivalent of a flying squirrel. And then the quoll is a marsupial equivalent of a cat, but they're marsupials. So those that reject the possibility of common design have to attribute the similarities to parallel evolution due to millions of beneficial mutations in DNA. The rest of the mammals, the other 30 or so living orders, are considered placentals or eutherians. All the rest of them complete their embryonic development while being nursed inside the mother's womb by a placenta, a well-developed placenta prior to birth. Now, marsupials depend on a placenta for a short time, but they're not classified as placentals because the duration of the nourishment is very short. They come out and then they begin to nurse. So there are dozens of living types of placentals, include rodents, bats, shrews, moles, and moles are not rodents. Hedgehogs, also not rodents. Lagomorphs, which are hares and rabbits, also not rodents. Whales and dolphins, which we're going to be talking about today and into the next episode. Primates, which are humans, monkeys, apes. Odd-toed hoofed animals, even-toed hoofed animals. Anything with hooves is called some sort of an ungulate. And then elephants, manatees, aardvarks, various kinds of carnivores, armadillos, pangolins, and so forth. So all of the different types of mammals are supposed to have evolved from the same non-mammal cynodont ancestor, some sort of a reptilian type creature. And meanwhile, the marsupials, the monotremes, and the extinct orders are supposed to have evolved the same jaw and middle ear structures as the placentals, at least 3 separate times by mutations in their DNA that were independent of but parallel to the mutations in the placentals. So here's how things are supposed to have evolved from fish to mammals. The ancestral fish would have given rise to crossopterygians such as Ichthyostogaleia, and the dipnoids, which is the lungfish, and one of those is supposed to have evolved into mammals, but nobody's really persuasive in their arguments that it'd be one or the other. And there would also be other amphibian orders, 2 living, others extinct, and one of those is supposed to have evolved into stem reptiles, the first amniotes. And then one of the stem reptiles is supposed to have evolved into flying reptiles. Some other one, maybe the same one, we don't know what other one, nobody has a candidate, would have evolved into marine reptiles like ichthyosaurs, sauropterygians, mosasaurs. And then also one of the stem reptiles would have evolved into some sort of land reptiles. And the land reptiles would have evolved into stem mammals. The stem mammals should have evolved somehow into flying mammals, and the land mammals and semi-aquatic mammals, the platypuses, the seals and so forth, the sirenians like manatees, and then fully aquatic mammals such as the whales and dolphins. So what was the specific type of mammal they evolved from? You notice there's a bunch of question marks on there because nobody has proposed this is the same mammal that evolved into the flying, the land, the semi-aquatic, and the fully aquatic mammals. Notice that we have all these unknown transitions. What are the known transitions? There are none. Okay, so I want to get into order Artiodactyla for a moment because they're supposed to be the ancestors of whales. Artiodactyls are hoofed animals that have an odd number of toes, 1 or 3. Those with an even number are called perissodactyls, and we'll get to those in another episode. The artiodactyls include familiar animals such as antelopes, deer, camels, cattle, giraffe, goats, hippopotamuses, musk oxen, peccaries, which are pig-like wild boars, and then the domestic pigs, the pronghorn, the sheep, fragulids, which are the smaller ones called chevrotains or mouse deer. Okay, so hippopotamus. Why is that supposed to be important? Whale DNA is supposed to be closer to hippos than to any other land animal. So where did whales come from? Well, some kind of an ancestor they had shared in common with whales. Huh? With hippos? Well, I beg to differ, and that's what I want to go into now. Did whales evolve from hippos? Evolutionists reject the idea that whales appeared in an initially complex form, which creation would say. Some have proposed that they evolved from odd-toed hoofland animals, artiodactyls, perhaps a sister taxon of hippos. So over many generations, the ancestors supposedly spent more and more time in the water, and they finally lost all their land features and became completely aquatic. So something along the line of hippo, which normally spends a lot of time in the water, spent more and more and more and more and more and more time in the water. It wasn't supposed to be hippos, just something supposed to be kind of like hippos. But eventually they lost their legs, they gained flippers, they lost their ability to do many things that are required on land and gained the ability to do many things that are required in water. So the argument for that scenario is that whale DNA is closer to that of hippos than to any other land animals. But really, how close is the DNA of whales to hippos? In order to validly compare the DNA, we would need to compare the complete genome. Here's one of the many problems. How many things have had their genomes completely sequenced? Humans and maybe some types of apes. I'm not aware of other things that have had the entire genome sequenced. So people say, well, DNA of whales is like hippos. Well, yeah, we can compare a small segment, but it's never been completely sequenced for either type. The National Library of Medicine database doesn't list hippo DNA as completely sequenced. It estimates the contents for hippos at about 2.4 billion base pairs. As I've gone over previously, your DNA contains about 3.1 billion base pairs as a human. So they're individual nucleotides we could read along, or we could say they work in pairs. A matches with C, A matches with T, C matches with G. So base pairs is pretty much the same thing as nucleotides. Okay, not a single type of whale has had its DNA completely sequenced. The blue whale is estimated to have about 2.7 billion base pairs. Okay, that means that in evolving from some hippo-like ancestor, the whales had to gain 300 million base pairs, 300 million nucleotides. Now, if you change one base pair, you can cause something like sickle cell anemia. But this requires 300 million, not just one, 300 million. The minke whale is estimated to have about 2.5 billion base pairs. That's 100 million more than hippos. The killer whale, orca, has about 2.2 billion. That would indicate a loss of roughly 300 million base pairs. And the pygmy right whale is estimated to have about 2.5 billion, which is 100 million more than hippos. And remember, none of these genomes have been completely sequenced. I'm just comparing the length. The length is so much different between hippos or any sort of hippo-like ancestor that we could imagine as compared to any type of whale in the world today. There would have been a tremendous loss or gain of information to go from hippo-like ancestor to whales. And then, did whales evolve from hippos? Okay, here's the tooth arrangement of hippos. They generally have 36 teeth, of which 4 are large and tusk-like. Then there's a whole group of whales called the baleen whales. What are their teeth like? They don't have teeth. I'll show you in very shortly what baleen whales have instead of teeth. And then those that do have teeth, some species have just a few teeth, but others have up to 200 teeth. And remember, this compares to 36 teeth in hippos. Some of the whales that have any teeth have only bottom teeth and a groove in the upper jaw where the lower teeth fit. None of the toothed whales have a tooth arrangement that's even remotely like that of hippos. And then there are, besides the difference of the teeth, there's something that are considered to be vestigial legs. They're supposed to be left over from when the whales used to be land animals, while the vestigial legs are not vestigial at all. They have a very important function, a crucial function. Whales are floating around in the ocean and they have to mate so there'll be baby whales. So what do we use, if we're whales, what do we use those so-called vestigial eggs for? To maintain position during mating. Those are not vestiges. Vestiges have no function. So-called vestigial eggs have a very important function. So where did whales come from? You will frequently see some sort of a chart like this, and I'm in a group on Facebook called Creationism, which ought to be called Anti-Creationism, and somebody has said it's obvious that whales used to be land animals, and look, we can arrange them on a chart, and we see that they have various shapes of legs, and then eventually we get to the whales. Well, yeah, we have a number of creatures with legs, L-E-G-S, legs. And then we have whales that have no legs. We don't have a gradual evolution from one type of so-called whale ancestor to another and finally come up to whales. No, we have a number of land animals that seem to have been suited for an aquatic life or a semi-aquatic life, but that doesn't mean that they evolved into animals that had no legs. There's no fossil evidence that any of these evolved from any other or evolved into any other. These are some of the fossil whales and the alleged transitions leading to them. Basilosaurus setoides from the Eocene is definitely, it is a true whale. And many of these are preserved in museums, and I appreciate those that have gone to museums and taken pictures and posted them, and I've done that with a number of fossils myself. So then you also have Myocetus, which is another Eocene whale, and Rhodocetus, another Eocene whale, and there's what the ankle looked like on his front flipper. It definitely had an ankle, and it had flippers, but it didn't have hind legs. So these at the bottom are supposed to be some sort of a whale transition from land to marine, Pachycetus, Ambulocetus. And if you look at those, yeah, look, they have elbows, they have front legs, they have forelimbs. So those that are desperate to have whales evolve from some sort of a lower animal like that would appeal to these and say, this is the transition from lower life forms, from some sort of a land animal to whales. We'll continue with this on the next episode. This concludes episode number 48. In number 49, we'll get into more specifics about why it's preposterous to believe that whales evolved from some sort of a land animal that wandered out into the ocean and gradually became more and more marine. So I guess I won't see you next time, but you'll see me next time.